So once again, welcome to the webinar. Welcome to Ambra Giulietti from VELUX. My name is Thomas Grabæk. I'm from GRAPHISOFT Center Denmark. We're here together with a webinar, the last sixth webinar in this series about the VELUX Project Development Guide. And today we're going to have a holistic view on the whole project, especially with sustainability and climate and microclimate within the building. Today it's not only the two of us, it's also more people from VELUX. The role of Shivani Mutatkar is played by Ilham Beg, who will join a little bit later. And then I think that we'll manage the whole hour. There will be some questions in the end. Webinar number 6, it's a holistic thinking in design people planet model. What we're going to do today is look at this special model for measuring sustainability within a project. We're going to look at how to simulate this and how it's calculated, especially on our project, on our building. When that's done, we're going to zoom out a little bit and look on inspirations from other projects that have been measured with this people and planet model and see how that can be used for your projects in the future. Then we're going to wrap up with the key takeaways and questions. So if you have any questions, please write them in the chat already. You might be able to get an answer in the chat, or we'll answer the questions in the end of the webinar. And before we end today, we'll also look at how the project, the project development guide, will continue after this webinar series. So the project development guide is a lot of things. It's a building, it's a project, it's a demo project that we have done, trying to show how BIM is the backbone of a whole project workflow. We have been inspired by a real project that is built just outside Aarhus in Denmark. And we have done the whole ArchiCAD model and a BIMX model that's easy to walk through, that combines 2D drawings with 3D model and all the BIM information. And then we've done the drawing material and the webinar series, and we put everything together so you can watch it when you like to. And it's on velux.com/project-development-guide. So go to the website and you can see all the content. The project is an amazing house, and the more we work with it, the more we love the building. It's really clever design from a sustainability viewpoint, and it's also a functional, great building, and it really have a beautiful design. It's done by art architects back in 2009, together with Espensen Consulting Engineers. And people are actually living there and have been for a long time. So I guess it works. I think we should move on to you, Ambra.
Yes.
And your presentation about the people and planet model.
Yes. And I would actually start with a little bit a step back and saying why VELUX is talking about holistic design. And that's because, yes, we are a roof window manufacturer, but of course the roof window is not standing alone out there. It's standing in a building. And that's why it's important to look at how the whole building performs and how actually people that are in the building can live in it. And as you can see here, we have a long history of demonstration building. And we started 15 plus years ago with making demonstration buildings and experimenting around holistic design and testing also how our solution perform in buildings. And here you can see also highlighted the Home for Life house, which is the one we are talking about in this project. And in all these demonstration buildings over the years, we used an approach that comes from Active House. So this is the way we have been looking at buildings through the Active House lens, which is an alliance that has worked on how to measure buildings, the performance of buildings. Putting together those three elements that you see in the image, which is comfort, energy, and environment. And in all those, you're seeing the elements of people and planet. And they did this developing this spider graph that they call the Active House radar, which measure different indicators. You see 4 indicators for comfort, 3 for energy, and 2 for environment. And here there's also a link to the Active House website where there are all the information and the latest edition of the specification on how to perform this radar. But it is using the Active House radar and also continuing with our research on buildings and building performance that we took some step forward, and we started to look at the exact 2 entities that we need to merge that are often seen separate in the building. And on one side, there's building biology, which is everything around the people and the condition that people need in a building to thrive. And then on the other side is the Earth system science, which define the absolute environmental limits that we have on the planet to keep it stable. And through the years, with Active House, the building biology part has been covered very well, but the Earth system science is also progressing very fast in the recent years. And that's why we have been looking at what the science is telling us. And I brought this video for you to see what they are telling us with the planetary boundaries. You hear this heartbeat that is increasing, is the heartbeat of the planet. So the blood pressure is very high. And that means we need to bring it, not only stop increasing the blood pressure, but bring it back to a safe status, a safe condition. Yes, and it's in exactly this.
And that's the science behind it. That
yes.
The heart and a heartbeat. And
the science behind is actually showing us that there are all these planetary boundaries that are basically showing the limits of the planet. So how much when is the planet healthy? And this is the situation now. So we have already transgressed actually 7 out of 9 of the planetary boundaries. And in the picture you see 6, but last year it was confirmed by the Stockholm Resilience Center that also the ocean acidification has been transgressed. So everything you see red is actually not good. So we need to bring it back. And this also has an impact for how we design buildings, of course. We are also part of it, of making the planet healthy. But the question is, how do we use all this information? How do we use this science? And how do we benchmark, in a way, our buildings and what we design? And luckily, they have told us that there are 2 main planetary boundaries that sort of regulate the whole system. So it is the climate stability, which we can measure with the carbon emissions, and we all know that. But then it's also the functioning ecosystem, and we can measure that through the biodiversity loss, which is a new indicator in the building industry.
And I didn't really understand it first, because I thought biodiversity in a building sector was what kind of biodiversity loss was caused by the building's placement on the ground, on the building side. If there were some animals that would no longer live there, or some plants that were distinct. But you told me that it was not actually that only.
No, it's not only about that, because actually I think I have some numbers here on why it is important and why the built environment is actually very accountable for that. And it's because the built environment is an industry that is very material heavy. We consume a lot of materials and a lot of raw materials and resources, and the extraction of those materials are actually causing a biodiversity loss somewhere else, far away from the building. And that is why it's not only the on-site that is, so what you mentioned about the species that maybe were living on the side of the plot, but it's also what happens far away where you source the material that we need to take into account.
That's actually a super sad problem, because we thought that looking at climate emissions and the carbon footprint, then we needed to go from concrete and bricks to wood.
Yes.
But now you're saying that wood is not only wood, but if it's sourced from the rainforest, for example, then it might be a problem compared to other kinds of sourcing of material.
Exactly. So it is also important to know where we are sourcing our material, and to make sure that we source from areas that are not that crucial for biodiversity. So not the rainforest, as you mentioned, but some other areas where it's actually better and we do less harm.
Perfect.
So going back to the people and planet model, we put together some indicators that we believe are crucial for the planet, which are, of course, the two already mentioned, the biodiversity loss off-site and the carbon emissions, but also the energy use, because energy still, we use a lot of energy and it's still needed in the buildings, and it's actually what is also very much regulated by legislation.
And we can see that in Denmark right now, that even though we're electrifying, and even though there's a big portion of the electricity that is from sustainable sources, then the whole grid is not capable of delivering energy in the same speed as we need it. So
exactly.
We actually need also to have less electricity, use less electricity, just to make sure that we can build the grid as fast as we are changing to use it.
Exactly, and that's why it's important to keep energy as an indicator that we really see how we are performing there, and try to make to use less energy, as you say. And then alongside the planet indicator, we add the people indicator that actually Active House has been using and has defined over the years, also, of course, adapting it to the European standards for daylight, for thermal comfort, indoor air quality, and also acoustic comfort. And we put them together into radar, you could say, very similar to the Active House radar. We are coming from there and inspired by that. And we are using a similar scoring system, just changing, of course, the planet indicators. And how we measure, we have it listed here. I will not go in detail into those slides, but daylight and thermal comfort, as I mentioned, follow the Active House standards. So I left the link and you can have a look to the Active House website. Indoor air quality and acoustic the same. And then for energy, we are actually developing the energy indicator even more, but we are still for now following the Active House 3 indicators that they provide. We just put it all in one to have just one score that it's easier to read and communicate.
And how do you calculate? So is that the area of the inside the spider web that will?
Exactly. The larger the score 1 is the one you have at the extreme, like at the external circle, and is the best. And then the smaller circle is the worst score. So the bigger the area, the better is score in the project.
And will you then end up with one score?
You could, yes. Active House actually makes an average of all the scores to get a one final. But what is interesting is also to look at this graph because it makes it easy to understand really what kind of compromises has been done in the building.
Exactly.
Because the point is not having score 1 in all. It's probably possible. But it's about the choices that you make and how you optimize to get the best out of both people and planet indicators.
Perfect.
And then for carbon and biodiversity loss, we have looked into, as I mentioned, climate science and the IPCC report, which shows the probability scenarios of being within 1.5 degrees. And it shows the 3 different pathways. So based on the pathways, how fast we are reducing emissions and how fast we recover biodiversity loss, then we score 1, 2, 3, or 4. Yes.
Perfect. So thank you for going through the model. We're going to be changing faces here. So it's actually really interesting that everything we've been through the last 5 webinars, it goes back to this holistic thinking about how to measure. I call it sustainability. That might not be the best word. So if we want to limit the amount of material, if we want to not only have materials with a low carbon footprint, but if we also want to make sure that it's sourced from somewhere where we don't hurt the biodiversity, if we also want to limit the energy used in the building, at the same time as we want to have a nice comfort inside, then there's a lot of parameters that we have to work on the same time. So it's really complex. And I think that as an architect, that is what makes it really interesting. It's having all these different parameters in play all the time and make sure that the end result is a great compromise between all the different factors. Mm-hmm. Welcome, Ilham.
Thanks, Thomas. Yeah.
So you're going to talk about the measurements on our building, the project development guide building.
Exactly. Yeah.
And you're also going to take some of the talking points from Shivani, who couldn't be here today because she's ill.
Yeah. So we talk about the calculation, how actually we did the calculation based on the simulation and put it on the radar that my colleague talked about. And also, as you said, showing some example of other existing projects that VELUX has done and use this model to communicate the result, and also showing the balance between the people side and planet side in the building.
Perfect.
Yeah, so to just ground the holistic people and planet methodology into the real life scenario, we have done some simulation using different tools that I'm going to show you which tools we have used and what is the result that has come up out of the project. Yeah, so if you remember, we have done some webinars before and we have talked about different aspects in this project.
Actually, I forgot about them, but then I saw them on the website, on the VELUX website, and I went through all of them again, and it's so amazing.
Yeah.
You don't even have to give them your email address or anything. No. You can just watch them online.
No, but it's a good place to maybe have a brief on some of the webinar we have done. But here you can see actually the tools we have used. There is like ecosystem of tools that we tried to bridge them to our ArchiCAD model, the BIM model. So we have tools like Climate Studio that we looked at in one of our early webinars, that you can do actually climate-based analysis, early decision makings. And then we have looked at iDice, which is a software that helps you to do thermal comfort, ventilation. So we have looked at how we did hybrid ventilation in this project. Also in our previous webinars, we have Daylight Visualizer. Actually, our last webinars, it shows how you can do daylight simulation and daylight analysis. And of course, Design LCA, which is a plugin for ArchiCAD that you can do carbon emissions and you can see your global warming potential.
And that's exactly why we call it the project development guide, because it shows this workflow from early sketch to final documentation and how these tools evolve during that process.
Yeah, so we have actually used the result from these tools and we have brought them together into the model and into the different indicators. So as my colleague showed you, the radar, we have the people side and we have the planet side. And in this case, what we have done, we have our base case, which is the result based on the like the old building, let's say. And then we have also improved case. So we have looked targetedly into some of the indicators, the one that we wanted to improve because we see potential there.
So the base case is the 2009
Yes,
project.
exactly.
And the improved case is our demo case or test project.
Yeah.
Which is done with, and to make sure that it follows the Danish building codes, we changed some materials and did the energy calculation as it should be to the current Danish law. So that's the improved case.
Yeah, so we have, as you said, changed the material to more sustainable material, and then we have also looked into the system. So we have looked into the hybrid ventilation, but we have not really changed anything to improve daylight because we believe the score was good, and we have not added any windows to say, but we have looked what if
we're
we
using
could.
newer versions of the VELUX windows.
Yes.
Actually with reused material and better EPD.
Exactly.
Yeah.
That for the material side, we are using VELUX EPDs. Back then, maybe it was more generic data. And then we are also using shutters EPDs and also looking into thermal comfort that where makes sense to have shutter on the window and also automation in the operation of the shutters. So we can see that we have actually improved a lot from the energy part and CO2 emission part. So we go from energy, let's say, I think 1.23 to 1 is because of the systems and also use of the passive strategies. And in the CO2 emissions and carbon reduction, we have actually achieved a lot, going from score 3 to 2.
Yeah, we're
and
taking half of the CO2 emissions from the materials.
Yes, and just proposing more sustainable materials and link to materials with EPDs, we could see this improvement. And that was again targeted. We wanted to try and experiment with that and see how can we be aligned with the regulation and also these pathways, as my colleague talked about, based on the IPCC reports and the probability that we can be within the safe zone. We are actually aligned with the pathway we have chosen with the CO2 emission we have in this.
But why are biodiversity so bad? We're scoring
Exactly. No,
nothing.
I just wanted to mention that it is not bad or anything. We have not really assessed biodiversity for this project now, but we want to mention that it is a very important indicator and it should be accounted in the radar because we need to account for the, offsite biodiversity that this material extraction for our project is causing damage. And we have not done this for this project because, back in 2009, it was not something that we were talking about. And also now I know that is something new and there are many talks about how the calculation to be done and what is the assessment, like more alignment between different way of doing it, but
another time.
Yeah, but it definitely need to be included in the radars for different projects. But we intentionally have not done it because we thought it's other indicator we can still talk about it
next time.
Yes. Yeah, and then so you have seen our result, our project, but now we are also showing you some other examples that we have used the model to support both the decision makings and communication. As I said, the radar using it for that purpose. Basically, it can really helps to know in the earliest stage what decision you make actually matters later, and you can see the impact later and the value of the model to help you actually in the decision making phase. Yeah.
Definitely.
So we have our first example, which is the living attic experiment. It's a real live renovation project in France. And as you might know that France has a large existing living stock and renovation is a big topic there. And there are actually many underutilized attic spaces. And then we have done this experiment to renovate the attic space so you can add on to your house without actually constructing new. So we want to promote that you have already existing square meter in your building that you can just use it without adding more material to your building. Yeah, and then we have transferred this attic to a healthy and sustainable attic. So it is in terms of
And usable.
Exactly, livable, usable. And just we want to also show that existing homes can be improved by combining daylight, indoor climate, energy performance, and also sustainable design principle. That's very important that we are following the principle of how to renovate in a sustainable way.
And of course, this is actually the better way to build is not to build, but to renovate the existing stock of houses, or just to add square meters for them, as done in this project. And we also wanted to do that for the project development guide. So our first thoughts were to find some kind of building that could be renovated, but that's just a really difficult example. So it's more to give a good example of how the whole workflow is from start to end, that we chose to do a new building instead of a renovation project.
Exactly.
And renovation projects also vary extremely from, this taking use of an old attic.
Yeah, and then we will also show in the next example that it doesn't need to be just a residential building. It can also be a commercial building. It can be an office building, but we will go into that. So if we look at the next slide, which is the radar, and this is showing the case before renovation. So we can see the house was performing actually poor in most of the indicators on the people side and the planet side. The daylight was not optimal, thermal comfort was not optimal, but we can see indoor air quality has been good, and the reason is because of the very poor insulation.
Exactly.
So the insulation was poor, the infiltration was high. Of course, air can come in and out, heated air goes out, cold air comes in, so that's why we don't have really a good thermal comfort. And the energy part, you can also see we are very bad in the energy because, of course, you need to use a lot of energy to heat and cool down the house. And also the CO2 emission is not good because of the operational part of the carbon part. It's also very bad. So we can see it is not the best house in terms of being healthy and sustainable for both people and planet. And then we have done the renovation case. We can see the darker green. It shows the renovation case, and you see it got bigger. We said when the spider gets bigger, it's better result. We have improved a light in the daylight part, thermal comfort part, indoor quality, of course, it was good, and the CO2 emissions. So what we have done, we have the made the insulation, of course, better. And then we have also looked into the systems, like hybrid ventilation, using natural ventilation to save some energy. And then also a smart solution, like having VELUX active, being a smart when to open the window, when have the shutters operation, and all these things. This can show that actually you can really go improve a lot in your energy, and this is impacting our CO2 emissions. So we have achieved the good CO2 emission, and then thanks to carbon payback. So the carbon payback of this house is 10 years. So it means that you are saving on your operational energy, and then in 10 years is a good amount of years as compared to the whole lifetime of the building. So that shows the success in this project. And then, with the other indicators, the thermal comfort, actually we have reduced to 90% reduction in the overheating hours, because it is one way that you can say that you are in a comfortable house, that you have less overheating hours. So this shows that this holistic renovation can really deliver improvement across all, both sides, people side and planet side. And I call it holistic renovation because we have looked into the attic as well as the whole house. We have also looked into the material choices and also the insulations and better U values, and then also looking into windows. If there was possibility to adding windows, let's say in attic, so we have.
It's a good way of paying for the renovation project or the energy saving. That you get more square meters.
Exactly, and then you have a livable space also on the top of your floor. So that's a big achievement as well.
And in the building regulations, the building codes in Denmark, it's all about new builds. And the reason, I guess, is because it's really difficult to find a way to measure on renovation projects.
Yeah.
retrofitting.
Exactly.
And this might be a good way of looking at it in a holistic way, because just looking at the carbon footprint is very difficult when some renovation projects are just energy renovation, where you add a little bit of insulation, and others are making more square meters or making apartments in an old factory house, something that has a high carbon footprint, lower than new build, but still high compared to just a small renovation project.
Exactly. I mean, the benchmarking or finding the baseline is important here. That what are you comparing your project to? That's also like an important aspect. We need to look at it when we are comparing and say, oh, was it actually a good project? Was it a success or not? We need to compare it with something. So the baseline, finding a logical baseline is also.
And paying back the carbon used for the renovation in 10 years is actually a good benchmark.
Yeah, actually, yes. And then the next project is called LKR Innovation House experiment. So this project is located in Osbiak. So it's like an innovation center for VELUX. So it's like a VELUX office. And so it has been an old timber warehouse, unheated. And then VELUX has decided to transform this project into an office place that now 500 employees are working there, doing R&D, product development, and working on innovation project. And like it's about 14,000 square meter office building. And then it's like another example to show that the transformation and using the people and planet radar could be applied into an office project, and commercial is not just used for the small scale. So if you look at the radar, as I said, this has been a not livable project before, so we don't have a case for that, like a radar case for that. But we have the radar when we have done the renovation. We have many roof windows in the project, so we have, of course, a good score for the daylight. Again, we have used smart VELUX system, so thermal comfort has been taken care of using the ventilative cooling and also use of passive strategies. Shutters on top of the windows, that indoor air quality helps it because we have natural ventilation, and of course we have also mechanical ventilation to have the minimum flow of air needed. We have acceptable acoustic score, energy score, good energy score, and also CO2 emission. We have actually worked very hard to be within the threshold, and we are future proof for coming years, 2027, 9, and 2030 with the score we have there, because we have really looked into the sustainable material and EPD data of the material we have chosen, and also the operational energy. We have tried it to be as low as possible. But I know that in this project, radiator has actually added a lot to the CO2 emission, because we needed to have radiators in the house, of course, and then they are really heavy in the carbon. But we have hybrid ventilation.
It's still difficult to do radiators in wood.
Exactly. Yeah. But then, so because it's a renovation project, the already existing material has been considered as zero carbon emission. And then on top of that, whatever we have added, that has been considered into the carbon emissions.
And of course, we're a little bit biased here, but both these two examples, but also our whole project development guide example, is that these skylights, they really make it easier to ensure that you have daylight, that you have sun heat in the cold season, that you are able to shut the sun out, so you don't get the overheating problems, and you need air conditioning. So that saves on energy. You still have fresh air. And because these systems are automated, you have a smart home system that will automatically make sure that you get the benefits. That is not only on paper if you remember to open the window and remember to close the shutter, but it kind of happens automatically. And then the material use for the EPDs, of course, when you have 3 layers of glass and you have a metal shutter, there is a carbon footprint. but it's actually a lot less than I thought, especially with these new VELUX windows where there's a reuse of wood.
Yeah, so what you are touching upon, I think, is very important because we are also aware of, the carbon footprint of our products are bringing. So we are actively working on that. And the new shutter we have launched, it is much, much lighter in the, in weight because less use of aluminium, and it has significantly increased the result in our EPDs. And also in our windows, we are also looking into the timber frames and how can we reduce the carbon footprint of our windows. So we are aware of that and we are working on that because we know it is adding to the whole building CO2 emission, and it's also a big concern for the designers, because of the regulation. So we need to also show them that, of course, our windows are bringing a lot of value, but it doesn't mean that they are adding a lot into the CO2 emission. We are also working on that side, but you need to work holistically on and showing the balance between the building performance part and also the CO2 emission part, planet part. So I think this radar actually plays a big role also in discussion with designers and let's say for this project, we have worked a lot with the engineers and architects of the house for looking at the radar, and it helps us for decision making, that how can it actually help engineers to decide what to do. Now we are, what is the trade-off, what is the compromise on different indicators.
But I also think that it will work as supporting arguments from the architects, because what architects has always wanted is a good sunlight, a healthy indoor climate. Often architects don't like the mechanical systems that we're living inside a plastic bag, and then we have all these mechanical systems pumping air in and out and heat. So the comfort is actually different when you have something that's with this hybrid ventilation part. And architects also like to have wooden materials and also a quality in product and material. I think all this comes together kind of in this radar look, that it's everything an architect would like to have, but often, perhaps because of lack of tools, some people hear that is okay, they like the color blue, they would like to have this, but now there's also an argument that it's better for people and it's better for the planet.
Yeah. And then this is another way that I just wanted to show that how can you can use different methods from the early stage of the design and reach to a good score. So for this project, like Healthcare Innovation House, let's say we have the people side, we are looking at the people side, daylight, thermal comfort, indoor air quality, and acoustic, and we have different options. And then it's up to us to choose which option, and then choosing from the, let's say, the menu we have there on the table, we come to some scores. And we can see, for example, in this project, we have windows from different sides on the facade, on the roof. So we can get daylight from multiple direction, and we have shutters that can helps us also, like blinds, helps us with the glare. And then the view, of course, having window, it helps you to have view to the outside. And for the thermal comfort, what we have chosen is we have chosen ventilation, cooling, using natural ventilation to cool down the indoor. And then we have draught control, like we have actively chosen that, and then we have looked into the operative temperature as well. Let's say it could be user or architect doesn't use dynamic shading. This is a choice. And then we have indoor air quality. So we have looked at the CO2 concentration, like how much fresh air is helping to reduce the CO2 concentration. And then we have looked at the choice of the material, like if there are, of course, there are particles coming from the material and you need mechanical ventilation for, the minimum. And then we have used natural ventilation on top of that. And then for the acoustic, again, we have used material that they can absorb, the noise and other measures to have better acoustics. So this is just showing that there are many options out there, and you can choose, and based on your decisions, the score changes. And this is an example that of what we have done in this project, what we have chosen for different indicator of the people side. And then if you go to the next slide, we have done it for the planet side. This is something we have also used in our project for the choices of the material.
In a little bit simpler version.
Yeah, a little bit simpler, but because this is like a huge building with a very different, said components. We have the foundation, deck. Yeah, I mean, the components is the same, but we have shown more choices. And then we say, okay, if you choose this material, let's say this foundation component, deck component, exterior wall, floor. So if you choose differently, of course you get different scores. So how could we get actually 4.6 kg CO2 equivalent per square meter per year? It was one of the reasons was being aware of our choices early in the decision, and then lead us to a very good score. And also the system. Of course, we have looked into the hybrid ventilation, heat pumps, and then passive strategies, also renewable energy, solar panels, that can bring a lot of value.
And that result on 4.6 is actually close to half of the Danish demands and building codes.
Yeah.
So that's really amazing that it can be done.
Yeah, but that's exactly the renovation case. So we need to also know like what are the targets for the renovation and then compare it.
And the point that we've been making throughout this project development guide is that you have to measure all the time, do some measuring early on, do the LCA, try different stuff out and measure. But of course, we cannot measure every possible solution. So that's why these matrices are a really good way of starting out, saying, okay, we think this can be done.
Exactly. Like the early, let's say, stage analysis or thought on all these things actually impact a lot in the later stage. When something is really late, you cannot change it if you have thought it early. It's like a lot of time saving, cost saving, and also performance improvement.
Exactly. And if we talk sustainability, then there's 3 pillars of sustainability. There's planet and people, and the last one is price.
Exactly.
And did you forget that one?
No, we have not added it in the radar. Because this is more about performance. That if you want to have a healthy environment, you should not really compensate on planet side. But cost, of course, is an important factor. It's not just included in the radar because it is, a third pillar, as you said. But it's super important that how does actually impact the cost. And if you have a building that is performing good in terms of building performance, of course it can bring, add on to your project, like your house or your property.
And we wanted to go this way with the project development guide, but since it's an international project and since it's already built and we are not building, it's difficult to bring the cost aspect into a test project like this. But it's really clear for me that the building that we have been inspired by is so cleverly designed that even though it's premium materials, it's premium solutions, I don't think it's much more expensive to build, but it's definitely saving that money back over the years of operation. And we did this small, in the 4th webinar, we did the small test that what happens if we take away the shutters from the skylights.
Exactly.
And that would actually make a lot higher heat gain.
Energy demand,
Yes, so the energy demand would be larger because we had to install 3 or 4 air conditioning units. And if you count the price of those into the equation, then the price or the cost of the project might not be larger in an LCC life cycle cost analysis that might spend the same 50 years that the LCA is.
Yeah, basically the impact or the result you see in the radar can influence directly the cost. As you said, like if we have a good energy, energy efficient building, then you can actually have higher in your price. And then if you have renovated, let's say your attic, so you have added onto your square meter, and then you have a livable space, and it's good.
And as an architect, we've seen that so many times that something is too expensive and it's taken out of the project to save money. But in the end, I'm not really sure that it always saves money, or if there couldn't be a more clever solution that would make it possible to get the same benefits without being more expensive.
But I think this is more about the communication. So if the architects communicate the benefits to the client and end user, and let's say talking about this carbon payback, that even if you spend money on more sustainable and like better materials, you get it back, and the time is short. Like in a short time, like in 10 years, you can actually get, because of your energy demand is less, you get it back. So it makes sense, even if you need sometimes to pay more.
And it's
still makes
easy.
sense.
It's just going through the exact workflow that we have shown.
Yeah.
Taking some decisions early on based on information and calculations, simulations.
Exactly.
Then you get this radar, which is the perfect communication tool.
Exactly. And then just coming to all the talk we had, and just briefly go over it. So we have what is the key takeaways about like this People and Planet radar and using the radar. We just want to have this message that is really important to have this balance between the human part and the people part, and not really go in a single metric isolation. Don't really focus on, okay, I need to cut the carbon emission down, or I need to bring my LCA down, or just focus on daylight. I need to have like amazing place, of course, with a lot of daylight. But think about, if you have so many windows, of course you get overheated. Then you need to put shutters on top of that. You need to be really careful about your material you are choosing to bring your LCA down. So it's like it's not like we think about one target.
It's actually a big concern from architects that now when we have these really low LCA, CO2 climate impact demands, then it will ruin architecture, because everything will just be trying to put this down. So we have to do these cubic boxes with no windows and a bad indoor climate, and everything is bad. And this definitely shows that it can be a win-win situation.
Exactly. So that's also a good time that we need to really talk about it even more, that you cannot really separate these two from each other. You cannot separate the people health and comfort over the planet, or planet over the people. So they work together, and if you want to save the planet, having your CO2 emission low, you need to really think about the people who are also living in this building, as you said. So it's about this, and also, as we said, the decision making based on the radar or based on the matrix. So really think about early stage decision you are making, because it really impacts later in the project and also the performance of the project. Yeah, I think this would be the key takeaway for
Perfect. So that's the best way to wrap this up. Having this holistic thinking about the project, having this documentation method, this scoring card in the radar, it will actually show why everything we have done in this workflow points in the same direction. So all these webinars, except the one we're doing right now, are already online. They're more or less an hour each. They will go from, the first one is about sketching, how to do some early decisions for climate, how to do the volume test of the project, how to visualize early on. The second webinar is about detailing, getting more precise, getting all the construction documentation in place. And we also touched down on how BIM helps this process. That's of course the whole idea of the project development guide, but especially with the advanced possibilities of BIM objects. And VELUX has made some really amazing objects that not only makes it easy to do the 3D model, but it also have a lot of information about the products and EPDs and how to install and everything you want to know. The third webinar was the engineering one, where we were showing how to model the MEP systems and also optimize the structural system of the building. And by optimizing the structural system, we actually found out how to save materials, so how we could lower the CO2 emissions just by doing a very fast test. And I think that's actually also the strongest argument for doing a BIM project. It was so easy just to sending all the information to the engineer. The engineer could almost automate every part of the process, sending it back so the architect could see what to change to have a lower carbon emission. The fourth webinar was about how to calculate LCA directly on the BIM project, and also diving down to how these EPDs work and how they describe the climate impact of real products. Last week, we had the fifth webinar about daylight, and especially about how to measure daylight using the VELUX Daylight Visualizer software, and figuring out how not to have too much sun, too little sun, and how to avoid having too many light sources, electric light sources inside the building. And then today we've been stitching everything together and trying to measure on if we did well, and we did well. So everything is good now. Next steps are the website is there. And within the next week, we will update with the recording of this webinar and also an update of the drawing material. And what is not very often seen in projects like this is that you can download the BIM files, you can download the drawing materials, you can walk through the BIMX viewer and see the whole project. So you can see how we did everything. And that will be updated on the website. We'll be started working on a small PDF guide about the workflow, the project development guide, and that should be out around summer. And then after summer, we hope to bring some more videos, which would be click-by-click tutorials about doing a project like this. So that's everything project-wise. Do you have any questions from people attending that we should answer here? I know that Alberta and Ambra has been busy answering in the chat.
Yeah, I can see one question that one person is saying, yeah, the windows, especially the bigger size, can cause overheating. And then why not? What is the solution from manufacturer like VELUX that can solve the problem? And I can see.
And the answer is
yes.
Watch webinar number 4.
Exactly. Yeah, of course they are. We have the heat protection solution. We have interior blinds, interior protection, and exterior protection. So they play a big role. We have done analysis that, let's say, external heat protection can have a 7 degree down in the temperature indoor. So they play a huge role when you know when to operate them. That's why we also have the smart system. If you forget, let's say, to do it on time before it gets too hot inside.
Yes. You don't have to leave work and go home to roll down the shutters. And this problem will get bigger and bigger. Today is the end of May, and in Copenhagen we have 25 degrees of heat. Throughout Europe, it has been much, much worse. So we're seeing that we will get more sun, we'll get more heat. So we definitely need to make buildings that are fit for the future. When we look at the demo house for this project, the Home for Life building, it's so cleverly built because we have this huge roof that extend outside the walls, so it makes sure that the sunlight in the summertime will not hit the windows and will not overheat the building as much. In the wintertime, when you have the low sun, it would actually allow a lot of sun getting in by the facade windows, but also the south-facing skylights. So you get a lot of heat gain in the winter, and in the summer, You have the shutters that are on the outside, so heat will not get in, and they are expensive. And the VELUX smart solution is also expensive, and they have a CO2 footprint, adding those kind of shutters to the project. But when you do the LCA, and the reason to do an LCA is that if you calculate over a period of time, we calculate for 50 years, you can see why it's cheaper and why it's better to do those more advanced solutions and build them into the whole design of the building. So actually that question just kind of frames everything we've done with this project.
And it's interesting to see that other participants are also answering the question to each other, and they are talking the same, that it's not just about one strategy. It is like a combination of using the natural ventilation to get rid of the heat, use the passive strategies. And of course, you cannot just put the active system. People do that, but you need to be aware of the negative side if you don't really open the window and everything is packed, as you said, to just be comfortable inside. Think about the indoor air quality and the energy cost and the energy demand and all these things. So it's like you need to, that's why we have this radar, to know the impact of others if you just have an active system and just HVAC system.
And going through this workflow, we've shown so many tools. Of course, BIM as a methodology is a big tool, but there's also been a lot of other tools, other softwares like IDA and Climate Studio and Daylight Visualizer. And there's also been a lot of tools like the radar for people and planet model. So there's so many tools, and some might say that, okay, if we just have those tools and give them to the engineers or the contractors or the users, they can just design themselves. Other will say that now we really need architects to try to bring everything together in a clever design. Some architects might say that this makes it too complex to design buildings. Couldn't we just go back to aesthetics? But I think that this really shows why architects are needed and why we need to be a lot smarter than we might be today, using all those tools that are out there.
Yeah, and also maybe one thing to add is not just about architect's role or engineers. I think it's more if you do it together, when you have this communication and bridge the gaps, and engineers talk with architects when it's needed, not as very late, and architects also communicate in an early way to engineers or contractors, homeowners. I think it's more about the collaboration to come to it's not like one person.
Definitely.
It's not like in isolation. It's
also bringing contractors and users into the equation.
Yeah.
And to make that work, we really need to be able to talk the same language.
Yeah.
Yes. So that's all for today, and that's all for this series of webinars. I hope that you have enjoyed everything we've done, and you also became a little bit smarter. I become a lot smarter, I think.
Yes.
I seem smarter in the webinars now than I did in the first ones.
Yeah, that's good to hear.
So we're going in the right dimension.
Yes.
I hope to see you out there again. Please use the website. Please use the LinkedIn chat. To make sure that you get your answers to your questions, and please ask us in the future if you have anything on your mind. Thank you to you, Elham, for joining me here. Thank you to Ambra Gugliazzi for also being on the show. Shivani Mutatka has been on several webinars, couldn't be here today. Lorena Jelinek is behind the scenes today from Rome, making sure all the technical things work. Alberte Grosdøl-Bunde has been doing the whole project as a project lead from GRAPHISOFT side, and Martin Lett Hansen is a project owner at VELUX. So there's a lot of tools and a lot of people who have made this work.
Exactly.
Thank you to all of you, and hope to see you again soon.
Yeah, thanks.